Hi kids. What we're going to do today is we're going to be talking about topic 6.4, dividing whole numbers by fractions. Now, in order to understand this better, what we're going to do is we're going to warm up our brain with a few exercises that will kind of do a pre-learning activity. So what I'd like you to do is I would like you to take out your marker and your marker board, please, or a piece of paper, depending on whether or not you're at home watching this video. Now, dividing whole numbers by fractions at the 6th grade level is really not that difficult if you take your time and you actually do the work. This is a skill you might want to practice on your own if you don't master it in class right away. But remember, it is something that is very basic math, just a lot of it in different steps. So it'll be basic math in various steps that you can very easily do. Okay? Now, let's warm up our brain a little bit. Let's talk about numbers that get along. One of the things I want you to remember is that when you're dividing fractions, okay, or even multiplying fractions, look for numbers that get along. For example, if I were to show you this list of numbers and this list of numbers, you would immediately begin to say to yourself, well, geez, certain numbers get along, or certain numbers are compatible. They share certain arrangements, okay? For example, you could take a look at these and you could say, well, you know what? Some of these numbers over here are even numbers. So that means that 2 is going to get along with 14. Now, it gets along with 14 by either saying 2 times 7 equals 14, or you could say something to the effect of 14 divided by 2 equals 7. So they multiply out to get, you can multiply 2 times a number to get 14. You can divide 14 by 2 to get 7, which is which is no remainder. So they get along well. You could then say, well, what other numbers do I have to get along? Well, certainly 2 is going to get along with 24, because 24 divided by 2 equals 12, or you could say to yourself, 2 times 12 equals 24. So 2 gets along with 24 through some sort of operation or numerical arrangement. So when you look at this, then you can immediately say, okay, well then 2 is going to get along with 18 also. If you look at 3, you're beginning to look at it and say, oh, well, you know what? 3 gets along with some of these numbers. 3 is certainly going to get along with the number 27. 3 will certainly get along with number 27, because we know that 9 times 3 equals 27. Well, if that's the case, you have 9 in our list, so we know that 27 and 9 are get-along numbers or compatible with each other, because they are an even matchup through multiplication. How about thinking of it this way? 27 divided by 3 equals 9. So you can reverse things in and out. Let's take a look at, tell you what, how about if we do this? Okay? On your marker board, I want you to list these numbers, and I want you to list these numbers on opposite sides. Then I want you to make any connections you can between the numbers. See if you can make them get along with each other without complication. So take a moment and do that. I'll pause the video while you do that. All right, let's take a look. Well, we can already say to ourselves that 2 is going to get along well with any of the even numbers. Okay? You could even say that 2 and 11 get along because they're both prime numbers. You could say that. When you look at 3, you say, well, you know what? 3 is certainly going to get along with 27. 3 would get along with 24 because we have 3 times 8 equals 24. So they get along. 3 is certainly going to get along with 15. 3 will get along with 18 as well. Now again, you could say 3 is a prime number, so 11 and 3 would get along because they're prime numbers. So those are kind of neat matchup. Right. If we look at 4, 4 is a little bit limited, isn't it? 4 is an even number, but 4 isn't going to get along with 14. It doesn't get along with 27. But 4 is certainly going to get along with 24, because if you look at the factors of 24, you have 1, 2, 3, 4, 6, 8, 12, 24. Well, 4 is a factor of 24, so it gets along real well with it. Okay? So that's a way of looking at it. You can think of them as factors. How about 4 and 15? That's not going to work. 35, that's not going to work. 18, that's not going to work either. So 4 is pretty much by itself with just 24. If we look at number 7, we could say, well, geez, we could actually ask ourselves, well, let's look for multiples of 20, or multiples of 7. 7, 14, 21, 28, 35, and on and on. And then you'll see that, well, gee, 7 is going to get along with 14. 7 is definitely going to get along with 35. So those numbers are compatible. So you can use multiples to do this, or you can use factors to do this. 8. Well, 8 actually, you know what? 8 can get along with 14, can't it? 8 can actually get along with 14 because the factors of 8 are 1, 2, 4, and 8. The factors of 14 are 1, 2, and 7, and 14. So 8 and 14 get along because they're both divisible by the greatest common factor of 2. So 8 gets along with 14. If you look at 8 and you say, well, 27, no, because the factors of 27 are 1, 3, 9, and 27, so there's nothing in common there. But 8 certainly gets along with 24 because 24 can be divided evenly by 8, which gives you 3. So 24 and 8 get along. Then we look at 15. Nah, 8 and 15, there's really not anything compatible with 8 and 15. 8 and 35, no. But 8 can get along with 18 because 18 has the greatest common factor, or has the factors of 1, 2, 3, 6, 9, and 18. And 8 has the factors of 1, 2, 4, and 8. They share a GCF of 2. So they get along well also. Boy, 11 is down there by itself, isn't it? How about 9? When we look at 9. Well, 9, let's think about the factors of 9. 9 has the factors of 1, 3, and 9. So let's just think about those. 9 certainly gets along with 27. Does 9 get along with 24? Well, the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Well, look at this. 9 and 24 get along because they have a greatest common factor. So we're going to draw a line to there. Well, you know what? Does 9 get along with 15? Not directly, but if you consider the factors of 15, 1, 3, 5, and 15, you can see that 9 and 15 both have 3 as a factor. So they get along. So we're going to draw a line from there. So we know that 9 actually could get along with 15. 9 really doesn't get along with 35, but it definitely gets along with 8 because 9 times 2 equals 18. And 9 and 11 really don't have anything in common other than they're close to each other on the number line. So there are compatible numbers. There are numbers that get along. All right. So what we're going to do, let's take a look at some numbers that are compatible and how they operate together. Let's take a look at this set of numbers. Okay? We have two fractions. Okay? Two fractions. And we have 2/5 and we have 1/8. Now right away you're looking at compatible numbers, but the rule with numbers that get along when you're looking at two fractions is you want to think crossways, diagonally, okay? So let's cross simplify. We're going to call that cross simplify. Okay? We're going to call that cross simplify. In other words, we're going to look like this and see if there's numbers, if the numbers get along. Well, in this case, you can see where 2 and 8 definitely get along, huh? Because 2 can go into 8 evenly. So 2 will go into 2. In other words, 2 divided by 2 equals 1, so we're going to make that a 1. But then we also have to take 8 and do 8 divided by 2, which equals 4. So then we're going to cross that and make it 4. Well, 5 and 1 is a non-defined number. It's neither prime nor composite. 5 is prime. So anytime you see 1 up there, you don't do anything to it. So that's how numbers get along and how you can cross simplify. Let's take a look at another example. Okay. Let's take a look at this example of numbers. At your desk, see if you can cross simplify them. See if you can cross simplify those. Okay, well, first thing you've probably noticed is that you have 4 and 7. They don't really get along, do they? But 3 and 9 definitely get along, don't they? 3 and 9 certainly get along. So what you could say is, you know, I'm going to say that these two can be simplified by using 3. So if you think the factors of 3 are 1 and 3, the factors of 9 are 1, 3, and 9, the GCF is 3, so we ask ourselves, 3 divided by the greatest common factor of 3 equals 1. So we can cross that out and make it 1. We also know that we can take 9, and 9 divided by 3 equals 3. So we can cross that out, and we can make that 3. So now we could actually just multiply across, or whatever we wanted. So let's try another one. Let's try this one. See if you can find numbers that get along. See if you can find numbers that get along there. Okay, if we look at these, we can ask ourselves, okay, well 1 and 26, don't have to worry about it because we have 1 up here. So 1 and 26 will stay the same. But 9 and 18 definitely get along, don't they? Because we know that the factors of 18 are 1, 2, 3, 6, 9, and 18. We know the factors of 9 will be 1, 3, and 9. So we have a GCF of 3 with those, and we also have a GCF of 9. Actually, we have the only GCF, which is 9. That was a mistake on my part. So we're going to take 9 and divide it by 9 and get 1. So we can cross that out and make it 1. Then we can take 18 and divide 18 by 9, the GCF, and get 2, and that becomes 2. So we cross simplify. Okay, now anyways, what we're going to do, keep that cross simplifying in mind as we are doing. Well, let's try one more. Let's try this one. See if you can cross simplify that set of numbers. Okay. Now, it's probably becoming obvious to you, and to a certain extent, that 1 and 3 don't have to bother with them. They're about as simplified as you can get. However, 27 and 3 definitely can be simplified. 3 can be divided by 3 to get 1. 27 divided by 3 will give you 9. So there you go.
We will be testing the fire alarm over the next few moments, so please do not respond to the fire alarm in the next few moments if you hear it. Thank you.
Okay, we won't. And let's move this over here. Now, let's go on to talking about division of whole numbers. Okay? We may pause and take a break right now, but Chris, do we need a break? All right, let's continue. Dividing whole numbers. In your book, it says, how can you find the quotient of a whole number and a fraction? Look at the division and multiplication sentences on the right. What is the pattern? Use the pattern to find the quotient for 4 divided by 2/3. Well, when you look at this in your book, this is in your book, you will see that we go from 8 divided by 4 ones equals 2, and then they bring it over here on the other side of the table, and now they have 8 times 1/4. If you look at this, we have 6 divided by 2/1 equals 3. Over here they have 6 times 1/2. So it appears that they're changing the division symbol to multiplication, and they're flip-flopping the numerator and the denominator. That seems to be the pattern. It's the pattern here. So this turns into multiplying. This flip-flops the numerator and denominator. 3/4 becomes 4/3. Division becomes multiplication. So that is going to give us the answer for division. If we switch the operations and create a reciprocal, we'll get the answer. Now, the book then goes on to further give you some more information. The pattern in the table shows a rule. So if you're looking at the pattern in your book, at the table in your book, the pattern in the table shows a rule for dividing by a fraction. Dividing, and here's the rule, dividing by a fraction, and you need to understand and know this, dividing by a fraction is the same as multiplying by its reciprocal. Now, two numbers whose product is 1 are called reciprocals of each other. If a non-zero number is named as a fraction, such as a over b, or ab, okay, a over b, then its reciprocal can be named ba. So in other words, 2/3 has a reciprocal of 3/2. So in other words, if you multiply 2 times 3, you get 6. If you multiply 3 times 2, you get 6, which gives you a whole number of 1. A whole number of 1. All right, next, okay, we're going to go into the book and we talk about further examples. Okay, so now we go back to the division of 4 divided by 2/3. Now, if you look at the example in the book, they have it set up in layers. Now, this is one way of looking at the layers. I'm going to show you another. Okay? 4 needs to be rewritten as an improper fraction. So it will be 4 over 1. Then we're going to bring down everything else to keep it the same, because you know what? This is sometimes an easy way of doing it. Now, 4 over 1, our next layer, 4 over 1 will stay the same. But now, because we see in the pattern in the table, we're going to change division to multiplication. Once we create multiplication symbol, we then have to create the reciprocal. We have to create the reciprocal of 2/3, which means we flip-flop. So now 3 goes to the numerator and 2 goes to the denominator. Now all we have to do in order to get our answer is multiply straight across. 4 times 3 equals 12. 1 times 2 equals 2. Now, this is kind of neat, but we don't want to leave it as an improper fraction. We want to convert it to a whole number or mixed number in 6th grade. So we would take 12 and divide by 2. 2 will go into 12 6 times, and that gives us an even number of 6. So this equals 6. Okay? So 4 divided by 2/3 equals 6. Now, you can save yourself some time if you look for compatible numbers. If I set my problem up again with the reciprocal, you will see that 2 and 4 get along. So we could actually say that 4 divided by 2 equals 2. And 2 divided by 2 equals 1. And then we can multiply across. 2 times 3 equals 6. 1 times 1 equals 1. 6 over 1 equals 6. So you can do it straight multiplying, or you can cross simplify and then multiply. So here's what we're going to do. We're going to try a couple of warm-up problems.